Okay, thank you very much, Esther. Hello, everybody. I would like to thank the organizers for inviting me here. This is a story, about how are we starting to see things because of quantum. I mean, how quantum changed the way we perceive phenomena. And the phenomena are high-level phenomena because I am just a plain engineer and we serve medical doctors, primarily cardiologists. And one of the problems they have is the problem of so-called non-ST elevation myocardial infarction. And in brief, it works like this: that you have a lesion inside the coronary artery. There is part of heart which becomes ischemic, and what they would like to have would be the simple criteria how to tell that something is wrong. Of course, in developed countries, we have many modalities for measurement of this fact, including biochemistry. But in low and middle income countries, it is quite frequent that ECG is the most they can afford. So we should not, behave selfish in this world, but we should supply them with better and better methods for diagnosis in a very limited environment. So this is one of the motivations. And typically, being a doctor, you look at the so-called ST segment, and you look at the elevation of this segment in the ECG. And this was the starting point of many studies. This was Wilhelm Einthoven Nobel Prize in 1923, as far as I remember. But soon it occurred that there are myocardial infarction that do not behave like this. They have different pattern, and for this fact that you can have depression, or you can have something that is neither depression nor elevation, but is so-called inversion of T wave, then the doctors have a problem because they have too many variants of a single symptom. So it is hard to say which of them is specific and which is not. This is the moment where we get on the scene. This is us. It is my team. I would like to thank my team. I'm the guy with the newspaper here, and here comes the magnetometry. If you look at magnetometry, it has been announced in 1976 in New York Times that Dr. Cohen is building a device, and it is sparkling. That it costed, you know how much? $30,000 at that time, and it was something that sparkled the imagination of the readers of New York Times at the time. The idea was the following: that, well, let's build a chamber isolated from Earth's magnetic field. Put a guy in pants inside, because you cannot have any metal objects. And together with this guy, you put a dog, and the dog is instrumentated, and it has a balloon in coronary artery, and you can inflate this balloon, and via this procedure you can control an infarction state in this dog heart. And it is you can do it several times. You can inflate and deflate this balloon, so it is invertible, and it is well-known animal model which was used these days. And along a few lines, you can place your magnetometer, and you can record the image of the magnetic activity. And what you see in the middle is the striking innovation from this research, which was the fact that if you inflate the balloon, you may observe such elevation of the baseline, which is of the same kind as the elevation of ST. So they started to think how to interpret this, and they found the following: well, if it is the constant value, so we have a constant elevation, then well, if there is a constant magnetic field, then there must be a constant current. This was the way they were thinking. So for this reason, they invented the so-called injury current. But if you think of it in physical terms, how can you have a constant current within the heart, which does not change in time? And the heart is not, it is a finite object. So it is virtually a nonsense from physical point of view, and of course of course this term is widely used all over cardiology in the world. But of course, being quantum, we know that you can have many sources of magnetic field, including magnetic field itself. So if you use bold contrast in MRI, you just introduce magnetic moments. Also, the previous presentation showed very nicely that reactive oxygen species have their magnetic moment as well. So in my opinion, this was the solution. And there are many interesting contributions to this fact, including a beautiful paper by Linus Pauling himself. So what we have done in this area, we put a very nice magnetometer, and the idea for this magnetometers came from Yannis, who is present here, and his colleagues a long time ago, and now it has been merchandised. So we just bought one item and we placed it over a healthy volunteer, and we put him in the cage. However, we can even use this technique now without a cage, which I will show you in a moment. And this was our initial result, which was the simultaneous recording of ECG and MCG. And we have a very nice argumentation related to shape, to morphology of both signals. As you can see, apparently they look quite similar. However, there is a substantial difference between them. And the substantial difference is such that the magnetometer registers a magnetic field which is proportional to current. And current is a change of potential or change of charge. Whereas, so it is time derivative, whereas electric measurement is always bipolar, which means that you basically measure a space gradient of the potential. And this difference is not easy to understand. Our group is probably the only one who understands this, and the effect is such because the ECG is a repeatable phenomenon. It repeats 60 times, per minute, which means that the full cycle has to close before another cycle starts. So it has to be a cyclic phenomenon. And if you measure it using ECG, you can just calculate the integral, and you can see that this integral for ECG goes somewhere up, and it does not close to zero. So MCG is not perfect in this regard, but it makes much better job than the ECG. So basically, we have proved that Ampere law works. So there is no big deal about it. But it was interesting that we have extended the range of the cardiac activity. It is important because it is about patient safety. Because if arrhythmic beat strikes at this time, will it be harmful to the patient or not? So the end of this cardiac evolution, it is essential to be determined where is actually the end of this evolution. So we extended it a bit to the right, which made us happy. And also it is the case of the STEMI and STEMI, because if the cardiac phenomenon is symmetric, ECG cannot see it because it observes gradient. If there is no gradient between 2 points, the ECG is blind. But MCG is not, because it measures at a single point. So this is a huge advantage of MCG against the ECG. And Here is the lady. It is essential to pick the right collaborators. She's my PhD student, and it's a quotation from her. Signal flows in my veins, and you can see that this is the case because this is the original trace, and this is what she did after several rounds of filtering. I mean, it's not very often that you see pictures like this, but we have more ideas. Here you can see another idea because we just put another electrode on the patient and we stimulate the patient. So there is an electric signal which goes throughout the skin of the patient, and we can observe it on ECG and on magnetometer. Concerning this, I mean, it's not 100% easy because we have to use, as you can see here, probably we have to use carbon electrodes. So they are carbon electrodes printed on some polyurethane or whatever, so that they do not harm the magnetic measurement. But basically, we can already do it on bedside. We have demonstrated this technique in the hospital. So you can see that we can synchronize using external source. It is well visible in both signals, so it gives us extra capabilities. Here you have extra systole, which is visible in both signals. And the another idea is such that if we have a signal of low quality, such as MCG, and we have a signal of high quality, which is synchronized with the first one, so why don't we synchronize bit by bit using ECG as the reference? And that's exactly what we did. And you can see that we were able to draw these nice curves from behind the noise. And now comes the art of interpretation. You can interpret. Sometimes you can leave the interpretation to the artificial intelligence. This is the group we know, and they have studied a huge number of patients using MCG, and what they write is that you may observe higher dimensional spatiotemporal electrophysiological structure. It is a triple cumulation of buzzwords. Because if you do not try to understand what is beneath the phenomenon that you observe, you have problems to pick the right language. So right now our direction is to try to understand as much as possible concerning the sources of the ECG and the sources of the MCG. So we travel in many different directions. We freeze the cucumber and record the spectra. Here is Buchner equation. It has not been yet acknowledged because I am just no one from Warsaw, Poland. But just give me a time. After 100 years, probably this will even become a Buchner equation. We have a nonlinearity in the response of the tissue, and we look at such models of localized electric polarization, because basically we found that there is no such thing as a free current inside of the human body, because we have mesoscopic structure and we have huge number of structures inside which limit any current you would put inside. So here are the models we look at. Here we are building a personalized model based on T2 from MRI, because basically the idea is such that any transport mechanism in human body is based on water. So if you have water, you will have higher conductance. If you have no water, you will have lower conductance. So basically, MCG can be measured at bedside together with ECG. And you can see how much the quantum measurement has gave us, additional dimension. We start to understand more due to the fact that we can measure magnetic fields, and I can see it very, very clearly. It's not what you measure, it's how you interpret. And theory for electric signal propagation and its magnetic correlates is still in 19th century, because essentially not much has changed from a point of view of bioengineering. I am built of a composition of metals of different conductance. So each part of my body is from different metal. So this is the official theory, what I'm telling you right now. You can read it directly from the textbook. As for us, our opinion is following Einstein, who wrote that it is the theory that decides